Welcome back to infyGyan, my dear friends. In this video, we have one very interesting factorial equation x factorial plus 1 over x plus 1 equal to x plus 1, where x is positive integer. So let's get started. As we can see, x cannot be equal to negative 1. So we can multiply both sides with x plus 1. In RHS, x plus 1 also. So denominator x plus 1 will be over in LHS. So I can write x factorial plus 1 equal to x plus 1 whole square. Now we know the algebraic formula a plus b whole square. It is equal to a square plus twice ab plus b square. Let's apply. So x factorial plus 1 will be equal to x square plus 2x plus 1. Now plus 1 and plus 1 will be over from both the sides. So we can write x factorial equal to x square plus 2 times x. Now x is looking common from RHS. So I can write x factorial will be equal to x times x plus 2. Now divide both sides by x as x is non-zero. So I can write x factorial over x equal to x times x plus 2 over x. X is non-zero. So we can cancel x from the numerator denominator in RHS. Now I will write recursive formula from factorials, which is n factorial equal to n times n minus 1 factorial, where n cannot be equal to 0. Now I can divide both sides by n. So n and n will be over. So n factorial over n equal to n minus 1 factorial, which we will apply in our LHS. So I can write our equation as x minus 1 factorial equal to x plus 2. Let me write here x minus 1 factorial equal to x plus 2. Now we will consider our substitution. Let x minus 1 equal to y. So from here I can write x will be equal to y plus 1, or x plus 2 will be equal to y plus 1 plus 2, which will be equal to y plus 3. So our RHS we will replace with y plus 3, and our LHS we will replace with y. So it will be y factorial equal to y plus 3. Now I can write y times y minus 1 factorial equal to y plus 3. If I will check y equal to 0, so LHS will become 0 factorial, which is 1. RHS will be 0 plus 3, which is 3. 1 is not equal to 3, so I can say y cannot be equal to 0. So I can divide both sides by y. So this y will be over. RHS will be 1 plus 3 over y. So I can write y minus 1 factorial equal to 1 plus 3 over y. Now factorial cannot be negative. So I can write here y is greater than or equal to 1 always. Cannot be less than 1. Second point, LHS is integer. So RHS must be integer. Now third point, 3 over y. So y is divisor of 3. So y will be equal to 1, 2, 3. Y cannot exceed 3 as it will generate fraction. Y cannot be equal to 2 also as it will generate non-integer RHS. So the accepted y value will be 1 or 3. Now we have to cross-examine which value is true through this equation. So if I will plug in y equal to 1, let me write here y minus 1 factorial equal to 1 plus 3 over y. For y equal to 1, for y equal to 3. So for y equal to 1, I will write 1 minus 1 factorial equal to 1 plus 3 over 1. So 0 factorial equal to 1 plus 3, which is 4. 0 factorial is 1. It is not equal to 4. So y equal to 1 is not accepted value. Now the turn of y equal to 3. So I can write 3 minus 1 factorial equal to 1 plus 3 over 3. So 2 factorial equal to 1 plus 1. So we can conclude from here 2 factorial is 2, 1 plus 1 is 2. So conclusion is y equal to 3 is our accepted value. Y was our substitution. So if I will write x minus 1 was y. So here I will be writing x minus 1 equal to 3. So x will be equal to 4. So our final answer becomes x equal to 4. Let us check. So I will write here check. Equation is here. I will write 4 factorial plus 1 over 4 plus 1 equal to 4 plus 1. So we know that 4 factorial is 4 times, 3 times, 2 times, 1, which is equal to 12 times to 24. So 24 plus 1, our numerator will be 25, denominator is 5, RHS is 5, which is true. Hence our final solution will be x equal to 4. I hope friends you will like this video. Thank you so very much for watching. Do not forget to like, share and subscribe. Bye-bye till next video. Take care of yourself. Goodbye.